Hi, this is a video for dbpresents.com. Being specific, it is about user stories in Scrum, which is one of the most known Agile methodologies used in software development. Please sit down and relax. I am going to go back to the philosophy that stays behind user stories. If you are interested in other software development related subjects, check dbpresents.com website or my channel on YouTube. Usually, when I talk about ideas behind Agile or Scrum, I return to Waterfall. It makes sense to me as Agile methodologies were born because Waterfall had problems. Agile was created to solve those issues. That is why I would like to spend a few minutes on talking about Waterfall and why tasks were replaced with user stories. I hope you have at least a very little idea what Waterfall is. This is the methodology which contains a few well-defined phases like gathering requirements, analysis, design, coding, testing, and user acceptance. The name Waterfall comes from the way how these phases are drawn, like a cascade of water. It is important that these phases are executed sequentially. Analysis starts only when gathering requirements is done. Designers come to the game only when analysts produce proper documents with analysis results. Coders begin their work based on the design. It is true to say that programmers do not have to know the requirements as they have to have the complete design documents. Testing is done when coders finished and so on. The project ends with user acceptance. Worth to notice is the fact that the whole process takes place at the project level. Ideally, each phase is done once per project. Tasks are products of the design phase. Technical people break down the design documents to tasks which are passed to the coding phase. So tasks are placed between the design and the coding. Oof, it's enough of theory for now. Let me show you an example. I have a software system which is a dating platform for dogs. Dogs can create their profiles with description and photos. It would not be useful without searching possibilities, so they can find each other by location, race, maybe this one should not be here, size, it does not sound good neither. Never mind, let me show you what I mean. This is how the search form looks like. A dog can choose who it is looking for by selecting a location, a race, a size. There are three options: small, medium, big, just to avoid centimeters versus inches fights. And this is a sample profile. A dog can put a description here, something that it believes is the most important about it, and its photo. When you have some idea how this system looks like, I have to tell you that it has become a huge success. Millions of dogs use it around the world. The success has become so spectacular that the owners of the system said, "We have to take our chance and open it to new market, cats." Business people have identified two areas that need focus. We all know that cats are not the same as dogs, so the system should somehow distinguish cats from dogs. Another important difference is that there are outdoor and indoor cats. Indoor cats never go outside. I guess there are no such indoor dogs, and the system does not allow entering such information. It will probably require adding such flag to a profile and the search form. Let's take a look at tasks prepared by the Waterfall team. The first task is an extension to the profiles table. It says to add two columns, animal type and indoor-outdoor information. The second one is to make a change on the front end. Two fields should be added on the profile page. The third task is an extension to search engine. Both fields should be indexed to allow searching in the future. This task assumes there is a separate component used for storing indexed data. A scope of the work is limited to that component. In the fourth task, the searching page is extended. 2 new fields should be added and connected to the fields in the backend database and search engine. The next task is to test the CAT support. Work done in the four previous tasks is tested in this one. A tester should check if integration between all components works perfectly. Hopefully it does, but if we were sure there are no bugs, we would not create a testing task. We did create it because we know there are bugs, they just have to be found. To be consistent, the next task should be bug fixing. It can only be a placeholder because we do not have a list of bugs at the moment of the task creation. It's even worse, these bugs do not exist yet. They will be committed later when executing previous tasks. Now, let's take a look at architecture of our system. It consists of a database, a backend and a frontend. There is a separate group of people that work with a database. These guys have special power, NoSQL. Backend are taken care of people with Java, .NET or other similar skills. HTML, JavaScript experts are in charge of frontend. What is worth to notice here is that these waterfall tasks we talk about are strictly related to the system layers. There is a strong connection between architecture and tasks. Each task is designed in a way to be handled by only one of these groups. None of them goes across layers. And as tasks must match the architecture, they have to be created by people who know the architecture. So they must be technical people with deep knowledge about the technical side of the system. I have talked for a while about waterfall, so I must end up with problems. Otherwise, there would be no point going to Agile. Tasks have a few issues. First of all, a single task has no business value. Which user cares about adding a column to the database in the dating platform for dogs? No one. Indexing a field in the search engine? What the heck is the search engine? Completing all tasks have a value to users, not a single one. Detailed technical design must be done before creating tasks. It is a drawback because designing the system with technical details is often not shorter than implementing the design. I know it is probably an artificial example, but how long will you take to find a table where the animal type column should be added, decide on a data type, find a meaningful name and describe it in the design document? Now compare it to the effort of adding that column to the real database according to the design. For me, it seems pretty the same effort. It may mean that designing technical side of the system is a major phase in the software development, not coding. Tracking progress of the design is not an easy job though. This item is strictly related to the first one. As a single task does not have a business value or even is invisible to the users, it is impossible to test it, or at least is difficult. That is why the testing task is one of the last ones. Another important problem is impossibility of estimating bug fixing. Estimating bug fixing is generally difficult. In this case, it is actually impossible because the estimate is needed before you start coding, and at that time you do not even know what the bugs are. It's even worse. These bugs do not exist yet, as the programmers have not committed them yet. The last one I listed here is a problem or characteristic tasks depending on who you ask. I mean, tasks are suited for silos of competencies. Let me tell you a little about it. Silos are huge containers used in agriculture for storing seeds or some powder. It is also a popular term in software development, like we were not smart enough to invent our own terminology. But anyway, it is a graphic analogy and it suits well in my opinion. Important here are a few features. They are vertical and connected to each other at the top of each silo. In IT, a silo is a team of database developers, another one contains Java developers, etc. At the top of each silo is a manager. The managers talk to each other to coordinate work. That is the analogy for these connections on the photo. As you can see, there are no other connections between silos. It is also an analogy. SQL developers do not have to talk to Java developers. They can, but do not have to. Tasks are well described, so every team knows what should do. Going back to our teams, from the left side there are SQL developers, Java developers, and front-end devs. Each group is packed to a separate silo. This is how it is done in Waterfall. Contrary to Scrum teams, where people with different skills are selected and formed to a Scrum team. To make it more powerful, a business person is added to it, for example, a business analyst or product owner. Of course, more than one team can be built from such silos. Because of this, we have teams which are cross-functional. It means that each team is able to do any job as there are business people, SQL, Java and front-end developers. It does not automatically mean that they have enough time, but they are able from the skills perspective. It is important to notice that cross-functional is not the same as each person can do anything. This is not a requirement. It is enough if the team as a whole can complete each task. It is time to talk more about Scrum. This circle with arrows is strongly connected to Scrum methodology. The cycle represents phases that follow each other: analysis, design, implementation and testing. This is pretty obvious for anyone familiar with Agile, but what I need from this diagram is that it happens on the sprint level. All these phases should start and finish during one sprint. When we go one step higher, we will see multiple such cycles on the project level. It is very different from Waterfall, where each phase took place only once per project. Let's have a look at such cycle. An input has to be put into the cycle. This input is called a user story. It is passed to analysis, design, implementation and testing. These phases are repeated if needed. When the testing is successful, a new feature in the system is produced. Knowing that, we are ready to think what these stories should be. First of all, each story should have a business value. If you still remember waterfall task that we saw a few minutes earlier, the task to add 2 columns to a table is definitely not a user story. It is difficult to imagine that any client would request or pay for adding columns to a database he/she does not even see. A story should describe what the user wants to accomplish. In Scrum, we want to deliver software that helps user, so more important is to solve users' problems than implementing what the user thinks he needs. It is better to know the original issue or a need rather than blindly implementing a design. As a user story should be analyzed, implemented and tested, the story must be testable. This is the third requirement listed by myself. Now, when we know what rules stories should obey, let's take a look at some examples. The first story says, as a user, which is a cat, I would like to register in the database as a cat. Currently, I can only do it by pretending to be a dog. It is written from the user's perspective. We know what the user needs and why. It is also testable. We can ask a cat to register and see if it succeeds. The second story is described in this way. As a user, a cat, I would like to see in other users' profiles if they are cats and dogs. I do not want to waste my time reading what dogs do. This is also a good user story. There is a user which expresses his needs. There is a value and a way to test it. The third story adds filtering by animal type. A user wants a possibility to search for cats. The story is again described from the user's perspective. How the user need is solved depends on the Scrum team. When we all have seen some user story examples, I would like to spend a few minutes on thinking about relation between architecture and user stories. As all stories are written from the user perspective and the user does not know the architecture of the system, there is no visible relation. Actually, there is, but user stories ignore the architecture and focus on fulfilling user needs. Hence, they often go across layers. One user story may require work on the database, the backend, and the frontend part. User stories may and should be created by business people or even users. It is totally opposite to tasks in Waterfall. Generally, user stories have a free format, but to assure they focus on the business side, it is recommended to use this template. It will help to remember about 3 questions: who needs what and why. We are almost at the end of this presentation, so I will let myself remind main principles of user stories. They should have a business value, describe what user wants to accomplish, and to be testable. It would be missing an opportunity to talk about user stories and not mention prioritization. Imagine a backlog with user stories. Each of them has some business value assigned. For simplification, I assume it was possible to put money amounts for each of them. In reality, it is usually not so easy, but an estimation also works. So there are stories with business values denominated in dollars. Backlog should be prioritized. In this case, the easiest way would be just sorting the stories in descending order by business value. It is not the only option. It could be even better to use return of investment, ROI, value, which is a business value divided by a story estimate. In story points, for example. Anyway, the backlog should be ordered and prioritized. This is a very important aspect of backlog because the stories should be worked on from the top to the bottom. It may happen that the project will be cancelled at some point before completing all these stories. It could be client who is satisfied with what he/she got so far, or the company which has run out of money. It could be anything. From this or the other reason, some stories are not implemented. but these stories from the smaller business value in the backlog, so the waste is minimized. As we are at the prioritization, there is one more thing I would like to mention: the Eisenhower Matrix. You might have heard about it from personal coaches. These forks that tell you how to live. It's great for prioritization, so it works in Agile too. There is an area with two dimensions: importance and urgency. Everything we do is somehow located on this surface, somewhere. There are tasks that are urgent and important. For example, when your house is on fire, firefighting is urgent because the next day the fire probably will not be there anymore. And it is important because lack of reaction will result in a necessity of looking for another place to live. On the other hand, when there is a cool outside and you walk by an ice cream store, buying one is not urgent because the next one is nearby, and it is unimportant as you will not overheat without it. To sum up, everything we do are somewhere on this two-dimensional surface. It would not be very useful without some conclusions. Here they are. Tasks which are not urgent and unimportant are wasting time. If you have items on other quadrants, focus on them instead. Activities that are urgent but unimportant can be easily reduced to the previous case. Just wait some time. After a few hours or days, they will not be urgent anymore, and they have never been important, so they could be also ignored. I believe this matrix may save some of your professional and personal time. Thank you for watching this. More IT-related stuff can be found on dbepresents.com. Subscribe to be notified about new videos. Click the thumb up if you liked it. Thank you.